And it says, how can you measure Earth's surface using a topographic map? Well, hopefully you guys know that a map is a precise model of the Earth's surface, but it doesn't show actual sizes or distances because those actual sizes and distances are far too big. So we scale them down so that they fit on a map. Okay? A map scale shows the relationship between the sizes and distances shown on the map and the actual measurements on the Earth's surface. Okay? That's important for you to know. Okay. It says, for example, consider a map with a scale of 1 to 10,000. What that means is 1 inch on the map is going to equal 10,000 inches on the Earth's surface. Okay. Also, maps typically have a compass or arrow that shows you at least where north is. And if you know where north is, of course, you can figure out the rest of the directions. Okay. Now, not all maps are going to have the same scale. Depending on how large of an area they show. So I'm going to show you guys a couple of different maps with different scales. This first one, I'm sorry about the glare. Let me see if I can adjust it a little bit. This is a topographic map of the Austin area. But it doesn't just show Austin. For instance, this right here is Giddings. This is Bastrop. Up here is Elgin. Way over here off the screen is where Austin is. But here's the scale right here. It says 1 to 250,000. So 1 inch on this map is going to represent 250,000 inches of actual land. Okay. Also, this is a topographic map, so it's showing us elevations. I know it's kind of hard to see because of the glare, but there are a lot of these little brown contour lines. For this particular map, the contour interval is 50 feet, so they're going to give you a contour line every 50 feet. Okay, this map has a different scale. This scale is 1 to 100,000, so 1 inch on this map would correspond to 100,000 inches of actual land. And contour interval for this map is 50 meters. This is actually the Grand Canyon map that normally is on the wall in the back corner of the room. Of course, we're down at the bottom, so you can't really see much of the Grand Canyon. But we're using a contour interval of 50 meters, and that should tell you, just looking at these lines, there's a lot of lines in a relatively small area. So you're talking about large changes of elevations, because if you think about it, 50 meters is over 150 feet. Okay? So that one is the Grand Canyon. All right, this one is the Physical Earth poster that you guys have been looking at. And it tells you down here what the scale is. It says 1 to 54,100,000, or 1 inch is equal to 854 miles at the equator. It doesn't work so well away from the equator because remember, we're taking a round spherical object, the Earth, and trying to put it on a flat map. And so the further we get from the equator, the more distorted the lengths get. But at the equator, there's your scale. Okay? And this one is not a topographic map, so we don't have any contour intervals. Okay, the lines that you see are plate boundaries. All right, last, this is our Lexington Quadrangle topographic map. The scale on this map is 1 to 24,000, meaning 1 inch on the map corresponds to 24,000 inches of actual land. Okay? Contour interval, because this is a topographic map, the contour interval on this map is 10 feet. So each time you cross a little brown line, you've gone up or down 10 feet. Okay, I want to talk to you next about slope. Slope measures the steepness from one point to another. You may have run across the word slope in math class as far as like the slope of a graph. You might have heard it described as rise over run. So in this case, the change in vertical elevation would be your rise. Okay, vertical would be like if you were graphing this, this would be along the y-axis. And the change in horizontal distance between the 2 points would be the run. For example, if you climbed 900 feet over a distance of 2 miles, so your elevation changed by 900 feet over a horizontal distance of 2 miles, then the slope is going to be 900 feet divided by 2 miles, which equals 450 feet per mile. Okay? And knowing the slope is very useful for many people, hikers, road construction workers, etc. Okay? All right. Let's look down here at our math problem. Find the slope from beginning to end of the hiking trail called Armadillo Alley. Armadillo Alley is this trail right here. Okay, let me see if I can. All right, let me see if I can expand it just a little bit so we can get all of it on there. Come on. Okay, Armadillo Alley is this path from A to B. Okay? It says use the map scale to estimate the distance from point A to B. So measure the distance of the scale on your finger, then use your finger like a ruler. Well, I don't really like that idea, but here's what I'm going to do. I'm going to say that looks like 6 centimeters is equal to half a mile. And I've got about 16 centimeters. Okay, so here's what I'm going to do. 6 centimeters is 0.5 miles. And if I have 16 centimeters, how many miles is that? Okay, you cross multiply, and you're going to get 16 times 0.5, that's 8. 8 divided by 6, I get like 1 1/3. They got 1 1/2 because they probably said that this right there was 15 and not 16, but that's okay. All right, so the distance from A to B is about 1.5 miles. And then it says to estimate the elevation at point C and point D. So this is the one, C and D. Here we go. So this is the one that you're going to do. All right. Well, hang on. Let's finish up with A and B. Find the difference between the beginning and the ending elevations for A and B. A starts at, let's see, this one is 8,400, okay? And we wind up, that's 92. Okay, these are going up by, the index contour lines, the dark ones are 200. So this is 9,200, this is 94, 96, 98, 10,000, and this would be 10,200. Okay, so at point A, we were at 8,000. At point B, we ended at 10,200. So we have 10,200 minus 8,400. That's a change in elevation of 1,800 feet. Okay, so that's where they got that. And again, I looked at the contour lines and I figured out where I was. A was at 8,400 feet. B is at 10,200 feet. Okay. And that's what they did here. Oh, I see why they did that. Okay, so this threw me off because they put point C and D, and I'm like, we're not doing C and D. So point A and point B, that's why I was so confused. Okay, so step one is to figure out how far it was. I'll just go with 1.5 miles, which is what they got, even though it's not exactly what I got. Then we needed to estimate the elevation at point A, 8,400 feet, and point B, 10,200 feet. We figured out the change in elevation, which was 1,800 feet. And now we've got to find the slope. Remember, slope is rise over run. Rise is our change in elevation. Run is our horizontal distance. Okay? Rise over run. So you get 1,800 divided by 1.5, and you get a change of 1,200 feet every mile.